So let's get started. I'm going to stop sharing and pull up the first of the lightning talks. So the first talk today that we have is the IIIF Universal Viewer for WordPress, an update from the Folger. And you should be able to see my screen with the video up. Great, okay. And you should be able to hear.
Good morning, everyone, and thanks for coming to this session of Lightning Talks. Today, I'm going to get us started with the IIIF Universal Viewer for WordPress, an update from the Folger. I'm Rebecca Niles from the Folger Shakespeare Library in Washington, D.C. I'm the developer for the Folger Shakespeare online, and I operate as the Folger's institutional WordPress support. I work with the digital media and publications team that includes Eric Johnson, Jessica Fraser, Jen Wood, Stacy Reddick, Sophie Bivik, and Mike Poston, all of whom have had a hand in the work I'll be describing today. As with most libraries, and particularly special collections libraries, it's very important for the Folger that our online offerings work effectively as a portal for users around the world to experience the Folger's unique collections. We have two main platforms where users can encounter our collections in the form of IIIF images. Miranda, our digital collections platform that includes catalog records and digital media, and Luna, the Folger's legacy image platform. Aside from these two platforms, most of the sites that the public uses to engage with the Folger run on WordPress. The Folger Shakespeare repository of plays and poems forms the Folger's online traffic powerhouse, netting over 1.5 million users and 10 million page views over the past year. The Folger blogs, as well as many of our research sites, also run on WordPress. So, we have cool stuff. Several IIIF servers full of cool stuff, and want to share it. What do? The Folger Shakespeare, despite its high traffic, isn't doing as much as it could to help get collections items in front of users. Out of the 3.2 million visits tracked on the Folger Shakespeare last year, only about 1,000 of them led to a visit to either Miranda or Luna. We want to do better here. But why bring the users to the collections when we can bring the collections to the users? The idea for the IIIF UV WordPress plugin grew out of the Miranda project and was intended to extend Miranda functionality beyond the site itself. We contracted with Parsons TKO to create a WordPress plugin that would bring our IIIF assets into our WordPress sites and that was easy for editors to use. If you want to check out the original code, you can use this link or just go to GitHub and search Folger IIIF UV. Developed a number of years ago now, the basic plugin uses shortcodes to fetch the specified object from Miranda. All you need is the Miranda items ID to turn this into this. The plugin fetches the images and associated metadata and then displays the results in a universal viewer widget. You can add other shortcode variables to control elements like caption display. The ability to add Miranda objects straight into WordPress posts and pages was a huge improvement. But it only worked for Miranda, and editors wanted the freedom to choose media objects from Miranda or Luna. But why stop at just Miranda and Luna? IIIF is built for sharing, and our IIIF WordPress plugin should be able to share any IIIF image. To support the use of any IIIF item, not just those from Miranda, I extended the plugin to accept IIIF manifest URLs in addition to Miranda IDs. Now, any image with the IIIF manifest works in the plugin, including Luna. There were some bugs along the way, but these issues have largely been resolved thanks to some excellent advice from the IIIF technical channel on Slack. Additional considerations came from reviewing use cases in both the Folger Shakespeare and in the Folger blogs and research sites. One feature in the works for the Folger Shakespeare is the ability for editors to adorn words and phrases in Shakespeare's text with various media, including the ability to use the IIIF plugin for images. In practice, however, the inability to focus the universal viewer on a specific detail of an item made it less useful for illustrating keywords or phrases. Blog and research site editors also wanted to be able to call attention to specific details of images. Being able to specify a default zoom and focus for the universal viewer on loading was obviously necessary. Support for manifest URLs also made it possible to set an initial zoom. While it's a little onerous on the editor for the moment, the use of URLs allows editors to use the Universal Viewer at universalviewer.io to set a default zoom, and then use the embed option to extract a URL that supplies the plugin with the zoom specs it needs. Another issue we noted is that many IIIF objects contain multiple images, and the first image in the set is often not particularly relevant to what the editor is trying to call attention to. We needed our WordPress plugin to support the ability to specify a particular image within a set that the Universal Viewer should use on loading, so that the user instantly can see what is of interest to them. To specify a starting page, I added a canvas start variable to the shortcode formula, which the plugin includes in its call to the target IIIF server. The editor just needs to know what page they want to start on and add it to the shortcode. So, what's next? Though these improvements have extended the scope and usability of the plugin quite a bit, I still consider it to be very much a work in progress. Next, I plan to focus on the following areas. First, upgrade from shortcodes to blocks. Shortcodes are becoming outdated by WordPress standards and are not particularly user-friendly for editors. I intend to eventually rebuild the plugin from scratch, taking what we've learned and applying it within a block-based framework native to the modern Gutenberg editor in WordPress. Blocks will provide the editor with a graphical interface for providing and adjusting input and for setting variables. Second, add additional features. Side-by-side image display, rotation, and other manipulation tools as are afforded in Mirador would be greatly welcomed by our editors, provided I can make them settable defaults in the same way that zoom and starting page is now. Thanks for listening to my lightning talk about the Folger IIIF Universal Viewer for WordPress. We hope to make our improvements publicly available sometime in the near future, but for now, you're welcome to get in touch with me, share your thoughts, and ask for code at rniles@folger.edu.
Okay, and so our next talk is about image alignment challenges.
Hi, my name is Anne McLaughlin, and I'm the Senior Research Fellow on the Practical Applications of IIIF, a Towards a National Collection initiative based at the National Gallery in London. My paper today is on image alignment challenges, the state of the art. This all comes out of a webinar that we hosted back in March of 2021, and particularly one paper, that given by Luca Carini about the Raphael cartoons at the V&A. It sparked quite a lively discussion in the question and answer period, and also an offline email thread that continued for quite a bit of time. Given this, we thought, why not host a seminar on image registration? This wouldn't be a big webinar of 2.5 hours, but instead maybe an hour and a half where people interested in the topic could come together to discuss questions, issues, and compare the ways that they're going about this in their own institutions. However, we were going to present the results of that paper here, but that hasn't happened. So instead, I thought I'd talk a bit about image registration as we do it at the National Gallery. When you come to the National Gallery homepage, this is what you see. We're on Titian's famous painting, The Death of Actaeon, and you've got a bit of text and an image. You see at the bottom that you can zoom in and out. However, I have no idea how they captured that image or even really how big it is. Well, here it is in its National Gallery context. And from the size, I can tell you just a simple camera snap will not be enough to get a really high resolution image, an image that will work for deep zoom and allow us to capitalize on the advantages that IIIF brings to the display and dissemination of images. Here is that image that you see, but in order to take it, we had to do it on something like this. You can see the painting at the top, and then on the screen, a little image of a detail of the painting, or a little tesserae, like it's a mosaic. And indeed, we mosaic these together. So here's the image of Diana again, and those are the 80 individual images that we mosaicked and stitched together in order to create the larger one. Each image overlaps the following one by about 20% on the bottom and on the sides, and this allows us to have points of comparison between the two, where we can match them up and then stitch the image together. So how do we go about doing this? How do we approach it at the National Gallery? Well, we do it by hand. And the first piece of software we have is then called NIP2. It requires that the user, from scientific, conservation, or photographic, define 4 points of commonality between image 1 and image 2, as well as image 2 and image 3, and so on and so forth. It's extremely labor intensive and very prone to user error. If you're off by even a pixel, that offage is going to compound as you go through. It also changes the resolution of the images, and it can't handle data cubes. We also use something called Ptgui. Now, Ptgui was designed to provide spherical panoramas where obviously we need it to provide flat images. Because of this, we sort of trick the software into doing what we want. We tell it that the photograph was captured with a very, very long lens, 8,000 or 9,000 millimeters. And also, we use Photoshop to figure out how many pixels each image overlines with the other one. We feed this all into Ptgui, and it helps it come up with points of commonality. Now, the advantage to this software is it finds those points of similarity automatically. However, we use about 300 of those per image comparison. So to do that, though the software does it automatically, it necessitates someone sitting at the computer and requesting that it find more points by clicking a button. It's not very labor intensive, but it is intensely boring. Also, it too can't deal with data cubes. However, it has worked well for both things in the visible light spectrum as well as X-rays. X-rays are a bit more complicated. We have to crop them first. We take them on old-fashioned film, though that is changing. And X-rays also have a parallax distortion because the rays come in from the side and distort the way that the image lies. Because of that, it's much more difficult for Ptgui to stack them together. We have similar issues with infrared and ultraviolet light, to say nothing of data cubes. Now, if you're anything like me, you've never encountered data cubes before you come and work for the National Gallery, and you can see that they pose additional challenges. Take, for instance, the Mercury image there. It's almost entirely black. Because of that, it's very hard to find those control points or points of commonality between image 1 and image 2, so creating a mosaic of something like the Mercury map is much more difficult using our existing methods. We also had a bit of a problem in that we had a lot of little tiny details from a lot of paintings, and we didn't know exactly where they came from. And with this, we decided to explore some more digital methods, more automated, in order to see if we could perhaps improve the process. We worked on visual similarity with the visual geometry group out of Oxford and Giles Burgall. And indeed, it worked out pretty well. We were able to take details and map them onto paintings. Here you've got a bit of the Virgin's golden hair, and the red lines show you where it ought to go on the painting itself. The same with the gold brocade fabric. We also have a PhD researcher with us. Her name is Maria Villafonte, and she's a joint doctoral candidate between us and Imperial College London. She's very graciously created the next few slides so that I can show what she's doing with regards to image registration. Here you can see she's going with the death of Actaeon as well, and she's got various regions of the canvas that have been elementally mapped in different sizes. She's then put those on top of the canvas using something called simple elastics. This actually comes from medical research, but she's brought it into the heritage world. Here you can see the process, the various different cubes aligning, and the end result. She's given us some nice zooms here, so if you look at the red box, it comes up here, and then you can follow it around as we get to finer and finer levels of detail on those maps. It's some promising research, and we look forward to seeing what she comes up with. However, we're not even the only one of our project partners for the Practical IIIF project that are working on image registration. The Victoria and Albert Museum is as well. If you missed Luca Carini's lightning talk yesterday, I suggest you go back and watch it, but you can explore their tools that they're making at the web address below. So, bringing this full circle in that seminar on image registration, well, I'm happy to announce that we now have a date. It'll be the 26th of July from 4 to 5:30 British Standard Time. There will be an Eventbrite link to sign up, but until then, follow our project at Practical IIIF. I promise the first of those that looks like eyes is actually an L, because we'll be announcing the program as well as when registration opens there. Thank you very much, and I hope to see you on the 26th.
Okay, so for our third talk, we have a session on using machine learning to migrate image metadata across continents. So let me reshare my screen really quickly.
So in this presentation, we're going to be asking the question, can we use IIIF and machine learning to migrate image metadata across continents? So starting with computer vision, in an industry setting, often what computer vision is trying to do is to take unlabeled data, and more specifically unlabeled images, and assign some kind of label to those images. So for example, whether a photograph contains a person or not. And data sets are often constructed very explicitly with the goal of being useful for training machine learning models on this kind of task. Now, in a heritage setting, we often have a kind of different problem, which is that we have collections which have labels, but those labels might not be consistent across these different collections. So whilst IIIF provides access to these images, we might have a challenge in being able to relate these images across these different collections because they have different metadata associated with each image collection. So how might we address this? Well, in 2021, of course, machine learning is one potential approach that could try and come up with some labels that are applied across all of these collections, which mean we can then think about them in aggregate more easily. And commercial services are one approach to doing this. Now, in this case, we have some slightly inappropriate labels, but they're also not particularly harmful. In other cases, we get some labels that we might not be particularly interested in, but there's still something here that might be useful. But one of the things to really be wary of with these commercial services is the kind of labels that they apply are not controlled by us, and we might get very inappropriate labels, as is the case with this example where we have slave shackles that have been given the label a necklace, which is clearly something we don't want associated with this particular image.
For this project, we decided to focus on photographs so they are visually appealing and will hopefully be easy to group. So can we create useful subject facets? Can we leverage the existing work of cataloguers who have been working on creating common subject headings for just such this purpose? Can we train our models on collections that have this data and apply it to a collection that doesn't? Is it going to be more useful than existing AI image tagging tools mentioned previously? For this investigation, we chose to have a look at the Library of Congress Thesaurus for Graphic Materials, or LCTGM, which contain around 7,000 terms and are intended for pictorial material like photographs. So where can we get this data? We need the data ideally in IIIF, but it must have the LCTGM headings that we need. We looked at a number of options. The first was the IIIF registry that has the potential to be a great place for quickly getting large amounts of IIIF data, but at this early stage there is only one institution represented. Going forward, this is definitely a place to watch. Looking for other sources of IIIF data, Europeana is a strong contender. They have lots of IIIF data to work with from 47 different institutions, and not only from Europe. Faceting down to IIIF photographs, it returns over 200,000 results. Europeana has limited facets available, so this is a great potential target collection. Wikidata is a great source of very structured data, and they have properties for IIIF manifests and also LCTGM subject headings. Unfortunately, there is only limited data with both these characteristics. Anyone can add data to Wikidata, so the content is very subjective to which institution is representative and which topics have links to LCTGM. Finally, we looked at the Library of Congress photograph collection. As you would expect, this has perfect LCTGM coverage with tens of thousands of images per category. These images have been professionally catalogued at the Library of Congress, but will reflect the historical collection cataloguing and digitalization policies of the Library of Congress. So, can we use the Wikidata's advanced querying support and structured data to quickly develop models, train them with the extensive data available from the Library of Congress, and set it loose on the IIIF data in Europeana to add subject headings and create clusters of related images? Will this help find those lost needles?
In turning to look at the data that we've collected, we have images from the Library of Congress and Wikidata, and here are some examples of the labels that appear in our training data. Now, there's a number of challenges in using these images as training data, and a lot of these stem from the fact that the labels associated with these images weren't originally intended to be used as training data. One of the ways in which that challenge presents itself is that the labels are often not evenly distributed across the collection, with some appearing much more frequently. This is much better in the Library of Congress collection, but you can still see that some labels appear much less frequently, and that makes it challenging for our models to learn how to predict well across all of our examples. The images themselves also pose some challenges, so we can see that sometimes the images are quite consistent, whereas other times what is depicted might be quite different across the collections, both in terms of the presentation, but also in terms of the content that is included in those photographs. So there's a range of challenges and opportunities presented by IIIF, particularly around getting data, but it's important, of course, not to forget the challenges that existing metadata schemes might pose, and that there might be limitations to those that we also want to consider. There's also a range of things that we can do to make this kind of machine learning application with IIIF easier, particularly adding content to IIIF registry or other aggregators. And briefly on our progress, so far models only do well on some labels, and we're focusing on getting more data, but you can see a fuller review of our results at this GitHub repository. And we're continuing to work on this work, and we'll be very keen to collaborate with others. So shortly, returning to our question of whether we can use machine learning to migrate images across continents, at the moment it's a maybe.
All right, and so next up, we have a talk on integrating IIIF in Scalar.
Hi everyone, my name is Crawford, and I'm a software engineer in the Arts and Humanities Research Community Group at Harvard University, and I'm the product owner for our Scalar as a Service platform. Over the past year or so, my colleague Tylor and I have worked together to integrate IIIF and Scalar. Today, I'm going to explain what Scalar is and why IIIF is a natural way to enhance the platform, run through the new media element we created, and demo the media importer we wrote to ease discoverability of IIIF resources. Scalar is a content management system designed to make it easy for authors to create born digital scholarship. As this clip from the Scalar promo video shows, it gives authors tools to structure essay and book-length works in ways that leverage the unique capabilities of digital writing, including nested, recursive, and nonlinear formats. Scalar enables users to assemble media from multiple sources and juxtapose them with their writing. Scalar content creators can annotate and comment on media, create paths through pages and content, and use built-in visualizations such as maps, timelines, and more to provide dynamic ways for end users to explore their Scalar books. Scalar is a free and open source platform. It's created by the Alliance for Networking and Visual Culture at USC, so it comes out of a community that understands the demands of scholars. The platform emphasizes linked open data practices. There's an API to share data created in Scalar, and the underlying data model is RDF-based. Scalar also encourages creators to reference a canonical media source rather than making copies and uploading them, and that model is very similar to IIIF. When using sources supported by the Scalar media importer, like the Internet Archive, Creative Commons, Omeka, or YouTube, Scalar imports existing metadata, allowing authors to automatically cite their resources while still playing the underlying media file. This open source, reusable, interoperable ethos is a natural fit for IIIF. As I mentioned, our academic technology team manages Scalar as a service platform for the students, faculty, and staff in the Faculty of Arts and Sciences here at Harvard. We've run it for over 2 years now and have reached over 700 users with dozens of Scalar books. We've also created customizations such as SSO integration, batch user importing, and more. And then we offer these as upstream PRs so they can eventually benefit the entire Scalar community. However, Despite the potential benefits, Scalar had not included any support for IIIF resources when we rolled it out. There was some support for deep zoom image files using OpenSeaDragon. The users were required to create and host the tile files themselves. And we saw an opportunity to enhance the platform by integrating IIIF. With Tylor's experience from working on our Scalar install and my knowledge of IIIF, we developed a new IIIF media type and a Scalar media element, which uses a slim build of Mirador 3 to display Scalar content. And this is what that looks like. So we can grab the manifest URL, go over to Scalar to import it. And you need to give Scalar the title of the media to be imported and the URL. We can then check the box to tell Scalar we're importing a manifest, and there we have it. And if we scroll down, you can see that we also parse the manifest to grab the thumbnail and pull out any metadata. Here, the title, subject, extent. And those are stored within Scalar in their Dublin Core vocabulary. So with basic IIIF support, our users were more easily able to display zoomable images in their Scalar books. However, if they didn't already know about IIIF resources, it's unlikely they would start adding them. Thankfully, Scalar showcases various media sources and partner archives. So we wrote a new media importer, which allows Scalar users to search the Harvard Art Museum's collections for IIIF content and import those manifests into Scalar. All the sysadmin for a Scalar install needs to do is drop in an API key. And this import process removes some of the barriers typically associated with reusing IIIF resources, because users don't need to know anything about IIIF to start using those IIIF assets in their books. So here's a demo of that process. The importer is located in the Scalar menu, like all other media sources. And we can do a search for anything here, but we'll go ahead and find the other canvas from the Mirador demo, the Van Gogh self-portrait, and go ahead and import that. And we can see that it grabs a ton of metadata from the Harvard Art Museum API. And we can go ahead and import that. If we go to the page for the media file, we see that we've got all the data from the manifest, as well as all the annotations that were generated by the Harvard Art Museum. So all of that comes over just fine. And we can get all of that by searching the Art Museum API within Scalar. And looking forward, we hope to write a similar importer for the Harvard Library Cloud API to allow Scalar users to pull in content from a digital repository service. And down the line, we're really interested in integrating image and annotation servers into our Scalar platform so that users can seamlessly create IIIF assets and store annotations from within Scalar. That's not something that's currently possible. That's something that we're really interested in doing soon. Thanks.
Moving on, we have a video about using a static site generator with IIIF. Sorry about that. So let me share my screen.
Hello, I'm John Meyerhofer, Director of Information Systems at the Hill Museum and Manuscript Library, or HIML. Have you ever wanted to simply share an image or images with students or colleagues using IIIF, but the thought of installing, configuring, and deploying a IIIF image server seemed overwhelming? Today, I'm going to talk about the 11D IIIF Manifest Generator tool. This tool can be used to share your images using IIIF all for free. The tool utilizes the IIIF API standard, the Mirador image viewer, 11D static site generator, and the Netlify hosting site to create an image presentations with deep zoom capabilities. Once you download the GitHub repository, you can install the application and then use the 11D to create a set of files. The project is seeded with content so you can get an idea of what you can do without any setup. With the site generated, you can drop or upload the application into the Netlify hosting site. This will create a unique URL for your content. With this URL, you'll need to update the site configuration so that the content knows where it lives. With the site URL updated, you can save and then regenerate your site. With the site regenerated, you can re-upload it to Netlify to publish it again. With the site generated and your URL updated, you can get a sense of the 3 examples that the 11D IIIF Manifest Generator tool gives you: a single image, a multiple image, and a full example of all the different configurations and parameters that are available to you for the tool. You can also add your own images by simply copying the folder, renaming it, and then adding your image to the folder. With our new image, we need to edit the metadata associated with that image. The metadata is this front matter that is in the index.html inside of your folder. You need to designate which folder the image or images are in. You need to fill in the name of the image. You can also change the title or label, the description, and rights. With all our metadata updated, we save the file, and then we can regenerate the site using 11D. Besides generating just the HTML files and manifest files, 11D also generates a thumbnail image for any image inside your application. With our new image and metadata updated, we can regenerate the site. Now we just need to redrop or upload the application to Netlify to see our changes. Manifests work in any Mirador 3 instance and can be used to compare or contrast images. HTML files can also be included in other websites using this iframe code snippet. Just add your own Mirador URL and the image will be added to your site. Here's an example website. Obviously, I've only had 5 minutes, so if you have any questions, feel free to contact me or read more about the project at this URL. Thank you.
Okay, so next we have a talk about the Mirador 3 text overlay plugin.
Hi, my name is Johannes and I work for the Bavarian State Library here in Munich, Germany. We recently relaunched our digital collections after, I think, almost a decade, this time completely based on IIIF. There's going to be a longer talk about this in another session, but I want to use the occasion of this lightning talk to talk about a specific aspect of the new collections that was very important to us during development. One of the main goals of the new version was to increase the utility of our collections for as many users as possible. Part of this was an increased effort to improve the accessibility of the collections website, and most importantly, the accessibility of the viewer. Since we are using Mirador 3, a lot of the hard work was already done for us, which is one of the many advantages of not building everything from scratch, but kind of relying on the community. One piece, however, was still missing. The viewing experience is very much a visual one, and users with impairments in that area are kind of left out. There's only so much you can do to render an image in an accessible way. The text is locked in the image. But lucky for us, we have very high quality OCR for over 95% of our collections, which is in absolute numbers a bit more than 345 million book pages. And we wanted to make use of these to improve the accessibility of the viewer, not just for visually impaired users, but also for able-visioned users. So enter the Mirador 3 text overlay plugin. I already talked about this, I think, on the working group meeting last fall, and it's now live on our Digital Collections website. It adds an overlay over the regular Mirador 3 viewer that renders the content of the canvas region below it as an optionally selectable text. This is all done with web technologies, which means you can do everything you can do with regular text on the web. For example, the text is part of the accessibility tree provided by the browser. So this makes it possible to have a screen reader like JAWS or Okta read a book to you, like this little snippet on the Bavarian State Library from a Guide to Munich Social Life from the 1800s.
Neither catalog nor books of graphic reference are in the room, nor are they to be had without special permission. But the chief inconvenience that you may have only one book at a time and you graphic must bespeak that the day before. The result is that the reading room is very scantily tenanted, and the graphic power of taking books away leads all who can to read graphic at home. There is no lack of civility or willingness on the part of the employees, but they are very few, are badly overworked, and underpaid. Graphic.
Yeah, but that's only one dimension of accessibility, although probably the most important one, since there are now over 1 million books more that were previously locked away in image facsimiles and can now be read by blind users. However, you don't have to be blind to have trouble making use of certain volumes. Language can be a great barrier as well. Having access to the text of a given region allows you to make use of third-party software to translate the text for you and help you in your research, even if you don't know the language it's written in. Having the text available also dramatically improves interoperability with other software. You can directly copy and paste a snippet into a paper you're writing, or in your citation management software, or wherever else you please. So what do you need for making use of this plugin? Basically, you need an IIIF presentation API endpoint, which associates text with each canvas. And this text can be associated as a line-based IIIF annotation, which is kind of the most basic format. This works, but I recommend using the other approach, which is kind of to link an OCR file with the canvas. And that OCR file can be in the Alto or HOCR format. This allows for more fine-based, more fine-grained rendering, and and kind of looks a bit better and it's less verbose. But either works, so do whatever suits your environment best. The plugin itself is open sourced under a permissive MIT license, available on GitHub, and can be integrated into any up-to-date Mirador 3 setup. Here's the links, and if you have any questions, suggestions, or need help setting it up, we've opened the GitHub discussions, so you can just kind of open a thread there and we'll take it from there. Thank you for your attention.
Next up, we have a talk on the Maps NavPlace extension.
Hello everyone, and thank you for joining us at the IIIF Annual Conference this year. My name is Bryan Haberberger. I am a full-stack developer in the Walter J. Ong S.J. Center for Digital Humanities at St. Louis University, and I am also a IIIF MAPS TSG co-chair. And today, I would like to talk to you about the NavPlace extension, which is a IIIF Presentation API 3 extension that the IIIF MAPS TSG group is currently working on. So why did this happen now? It was not some overnight realization that IIIF data would be greatly enhanced with geospatial descriptors. A lot of humanities data exists in the system, so that is media that pertains to humans and the things they have interacted with through time and across the planet. This means temporal and spatial characteristics are vital to properly explain this data. This is not a foreign concept in the IIIF APIs or in the IIIF communities. Some good parallels you could draw for things that exist in the API right now are the navdate property, as well as the support of temporal behaviors and selectors. So let's get into it. What is NavPlace? Simply put, NavPlace is a property that can be used with certain IIIF resource types in Presentation API 3. I'll illustrate that here with an example of a canvas. So here you see your canvas. Just like it has type or label or height or width, it also now has NavPlace on it. So I would like to use that parallel with navdate we talked about before to explain this a little further. Navdate says it is a date that clients may use for navigation purposes when presenting the resource to the user in a date-based user interface. So there you see navdate with a very simple value of an encoded date. So think about that in spatial terms. NavPlace will be a set of one or more geographic coordinate shapes that clients may use for navigation purposes when presenting the resource to the user in a world map-based user interface, such as Leaflet, Google Maps, OpenLayers, and of course there are many more examples of that out there. So here you see, just like the date was encoded in this special way, the coordinates are encoded in this special way, and this is called GeoJSON. So how did we get to this point wanting to develop an extension, and what is it like to develop an extension for the IIIF Presentation API 3? First, the IIIF MAPS community was formed, and after a lot of internal discussion, they decided that an extension to the API was worthwhile, and so the Technical Specification Group was formed. The Technical Specification Group meets monthly to develop the extension. An important part of extending IIIF Presentation API is to have a linked data context to provide vocabulary for your property and its contents. What that does is it gives clients a chance to validate against an agreed upon schema and be more accepting of the different sort of data types a value can take on, an array, a plain string, a language map, those kinds of things. Lucky for us, there was already a popularized schema for geographic coordinate data on the web. It's called GeoJSON, as I brought up before, and a linked data description for the standard was generated called GeoJSON LD. This meant we did not have to invent an ontology. A widely agreed upon schema already existed. So now we will get into the linked data aspect of things a little bit. So during the initial research phase, when we were trying to mix GeoJSON LD together with Presentation API 2 and 3, it became clear that the Presentation API 2 could not support this sort of data encoding, and neither could Linked Data 1.0. There are just unavoidable term and context collisions, and resolving them meant breaking the schema. So a very damning attribute of Linked Data 1.0 is that it cannot process lists of lists. So here you'll see this array, which contains two items, one the string hello, and one another array, good people. Here is a list in a list. Here we will look at why it's so much trouble that Linked Data 1.0 cannot process lists of lists. When it comes to GeoJSON, here's how it represents polygonal shapes, and encapsulating an array that encapsulates all the coordinates for that shape, when each coordinate pairing is, of course, an array. This means it's not possible to process GeoJSON polygonal shapes in Linked Data 1.0, which means no one would be able to use polygons to represent their data. The ability to represent polygons in geospatial data is an absolute must. So, what about Linked Data 1.1? Going into the playground and providing an object with the GeoJSON LD context, you'll notice that it can support lists of lists, and it completely resolves my object and assigns the proper vocabulary to everything. So here we've proved that GeoJSON LD will work with linked data 1.1. So now what about getting these GeoJSON LD terms into IIIF? Linked data 1.1 processing has a technique called scoped contexts. It allows us a minimally invasive way to include GeoJSON LD with the presentation API 3. So here's the context extension, which links out to a vocabulary for the navplace term, and then into that property scopes the GeoJSON LD context. In this way, the only thing it's focusing on is navplace, and we won't have any other term collisions with any of the other IIIF data. Now, that's a lot of technical talk you could get lost in. So to close here, I would like to show you what it looks like to use the navplace property. So here's a leaflet viewer where I've gone into it with a collection of manifests, and each of those manifests has the navplace property. So now, this leaflet viewer works as a collection viewer, where each one of my manifests is represented by a point in the view. Hopefully this view has given you an idea of how the navplace property is intended to be used. In the end, you are providing interoperable, web-friendly geospatial data assertions. This gives IIIF data a chance for representation in common geospatial UIs, referred to here as web maps. You're also enhancing the discoverability of your resource, making it available to spatial and perhaps non-spatial queries against the geospatial data and the metadata contained within navplace. So thank you very much for your time, and I hope you enjoy the rest of the conference.
All right, moving on. We have a talk about a iOS mobile app powered by the Art Institute's public API.
Hello, my name is Yujeong Lee. I am a student from South Korea and a recent graduate of Earlham College, where I studied art history and computer science. Last winter, I heard that the Art Institute of Chicago, one of the favorite museums for me to visit, released a public API of their entire collection. I was very excited to try to produce a mobile application using the public API. As someone who loves to learn more about art history at any place, I also downloaded a lot of different art apps to try them out. But one of the problems that I encountered was that many of these art apps really primarily recommended me to look at Western artists and paintings, which was perpetuating the Eurocentric art historical discourse that a lot of us are trying to overthrow. As you can see here, on both the WikiArt application and Google Arts and Culture application, two huge platform for a lot of people to study art, are recommending majority of male European artists for me to look at. Through this mobile application that I was developing, I really wanted to ultimately amplify underrepresented artists and artworks, and also provide a new way of engaging with art for the users. So this is my first iteration of the application that I'm developing, and currently the core functionalities are that users can scroll through all the artworks that are present in our Institute's API, and they can also search for specific keywords and also to click into specific works to view more information. So in this video, I am searching for the keyword Korea to just look at any art that was created in Korea in various dynasties, and also artworks that were produced by a Korean artist. So here I search for the artist Faith Ringgold, which to my surprise I found that there are only 3 artworks of hers that's collected in the Art Institute of Chicago. So, here's another thing that I want to share with you is if you watch this video again carefully, every time I type in a new word into the keyword search bar, the results of this application will get refreshed because it's constantly searching for works that contain that updated keyword, whether it be just the letter F or the letters FA or the word faith, or ultimately the whole phrase Faith Ringgold. And through this feature, I just had so much fun searching for different keywords, random keywords. I would search for, fruits like banana. I would search for different countries. I would search for very random words like investment, and just to see what kind of words would pop up. And I just want to end with sharing with you an artist that I learned about just by searching for different keywords. His name is Kerr Coppin, and these are very joyous photographs of different events, that were happening in the African American community in the late 1980s. As I continue to develop this application, I plan to incorporate interfaces that further guide users to interact with and learn about artists and artworks that are from traditionally underrepresented cultures and time periods. So for further information, I used the Swift language to program this in the Xcode environment, and really this app was entirely possible through the Generous Art Institute's public API and the IIIF's Image API. If you're interested in learning more, here is my GitHub repository that you can scan to be linked to, and I would really love to really hear back from any of you if you have any kinds of questions or suggestions or visions for the application. I would really love to connect with everyone here in this community. Thank you so much, and I hope you have a great day.
And we're down to our final two talks. Next, we have editing IIIF manifests in Archipelago.
Hello everyone, I am Allison Lund, Digital Projects and Metadata Librarian at the Metropolitan New York Library Council. Today I will be providing a brief overview of editing IIIF manifests in Archipelago, an open source repository system being developed and supported at Metro. Archipelago is a slim, smart, open source repository software built on top of Drupal. Archipelago leverages Drupal's core content management and custom Archipelago components, the Strawberry Field modules, to form a flexible and extensible digital repository system. More information about Archipelago can be found at archipelago.nyc and github.com/esmero. All data in Archipelago, including metadata for digital objects and collections, is stored in JSON and can be cast into different metadata schemas and displays depending on institutional and community needs. IIIF APIs and IIIF compliant viewer customizations are woven into Archipelago's architecture and functionality. Archipelago extends the IIIF Image API and Presentation API versions 2.1 and 3.0, and also features W3C compatible annotations. Archipelago ships with IIIF compatible configurations for Mirador, Internet Archive Book Reader, and OpenSeaDragon viewers. I am now going to demonstrate editing a IIIF manifest using Archipelago's metadata display preview functionality at archipelago.nyc. After logging in using my administrator account, I navigated to the metadata display list, which can be found at yourdomain/metadatadisplay/list. I am now going to open the IIIF Presentation API 3.0 manifest template. This is a Twig template that generates a IIIF manifest. More information about getting started working with Twig and Archipelago can be found in the documentation page links at archipelago.nyc. I am now going to select Edit, and then I'm going to open the Preview section and search for a source digital object to use for the preview. After selecting the object, you can see that the preview section opened up on the right side of the screen. The bottom section contains the output from the IIIF Twig template, so it is displaying the IIIF manifest for the selected digital object. At the top of the preview section, you can see the full JSON metadata record for the selected digital object. For this case, I would like to switch the linked data source value being used for the agent or creator metadata section in this IIIF manifest template, as I know that this selected digital object and others in my repository most often use the Library of Congress name authority source for this metadata. The Archipelago default version of this IIIF presentation manifest template is currently using the Wikidata agent as the source, and the metadata key source JSON key for that is EDM_agent. By reviewing the JSON record for the digital object selected earlier, I can check the JSON key and array setup I need to reference. For this, because I'm familiar with the data structure for this repository, I know that I need to use the creator_LOD JSON key for this case. Now I'm going to simply edit the default template directly, making a few adjustments as needed. Because the array structures for both the Wikidata agents and Library of Congress source data are set up in the same way, both are using the role label and name label properties respectively. In this case, all I need to change is the data attribute to the creator LOD key here. So I'm going to copy and paste this here. And now if I scroll up and select the preview button again to refresh the rendered output, I can immediately see that the IIIF manifest generated from this template is now using the Library of Congress source for the specified metadata section. I'm now going to save my changes so that all of the manifests being generated by this template use this new information. Now, if I refresh the public page for this digital object, we can see that the creator value from the Library of Congress authority source is also found in the corresponding metadata description section in the Mirador viewer, in addition to the metadata section in the IIIF manifest. This same process could be used to add and edit additional metadata values such as subjects from other linked data or controlled vocabulary sources found in your digital objects and collections data structure. You could do this to further enhance the manifest being generated within your Archipelago repository. To get started working with IIIF manifests in your own archipelago, you can find a guide to deploying your own local instance at github.com/esmero/archipelago-deployment. If you cannot or are not interested in deploying a local instance, you may also request a free user account at play.archipelago.nyc. Thank you very much for your time and attention, and thank you to the IIIF Consortium for the opportunity to present this topic during the IIIF conference.
Okay, and so now on to our final talk for this batch of lightning talks. This is a talk about IIIF Nest and IIIF Cloud.
Hello, I'm Leander Seige from Seige Digital, and I'm going to share some insights into our current projects, IIIF Nest and IIIF Cloud. In the past years, we have converted data from many museums, libraries, and archives into IIIF formats to use them in our IIIF compatible applications. This includes, for example, data from the Städel Museum Frankfurt, from the Metropolitan Museum of Art New York, from the Zeppelin Museum Friedrichshafen, and many more. These IIIF resources are now openly accessible under the collection URI shown on this slide. The toolchain we used in the past was quite complicated and not very flexible. It creates static files and only supports IIIF Presentation API 2. So we decided to develop a new tool to create IIIF resources dynamically and to support multiple API versions at the same time. We named this new tool IIIF Nest. IIIF Nest consists of three components. First, in green, there is the backend server that manages an arbitrary number of import modules. Each importer is responsible for pulling data from the data source, for converting the metadata to our internal data model, and for pre-processing the images for the IIIF image server. The second component in red is the IIIF presentation server. This component responds to HTTP requests for IIIF resources. It collects the necessary data from the database and generates the IIIF resources, for example, manifests or collections on the fly. The third component in blue is the graphical user interface for the backend server, which implements a convenient way to control and manage the conversion tasks. Here is a screenshot of the dashboard of the backend user interface. The dashboard provides an overview of the statistics and states of the import modules. Conversion tasks can be started and monitored in the individual modules. For instance, it's also possible to view the latest image that was recently converted. We have also implemented a simple browsing function to go through the items of each data source. All in all, I think the functionality of the user interface has still much potential, and we see many features that can be implemented in the future. IIIF Nest is compatible with the IIIF Presentation API version 2 and 3. Of course, each entity has a unique URI. The desired API version can be requested via content negotiation. Other entities like canvases or ranges will also be resolvable in the future. The data model is already prepared for that, but it has just not been implemented yet. For the image API, we are currently using the well-known IIP image server, which supports Image API version 2. During the development of IIIF Nest, we converted the entire online collection of the Städel Museum Frankfurt, 27,000 records, and the entire online collection of the Museum for Kunst und Gewerbe, Hamburg, 14,000 records, to IIIF. Both datasets were harvested using the OAI PMH protocol. However, other interfaces can easily be adapted for IIIF Nest as well. And both collections are now available online. Please feel free to take a look at the data. The slides with the URIs will be available on our Twitter account or on the conference website soon, I guess. But please remember, these are not official services of the institutions, and the system is still under development, so the IDs may change or even disappear in the future. IIIF Nest is currently available as a development installation on IIIF.cloud. We are open to collaborating with institutions to improve IIIF Nest on real-world use cases and to develop institutional IIIF services. Once IIIF Nest has grown beyond its experimental status, we plan to release the code as open source software. Thank you very much for your attention, and please contact us with any questions or comments. Thank you.
So that is about it for the lightning talks today. We are now going to take a short break before we start the concurrent session. So thanks to all the speakers who recorded their talks, and thanks to all the attendees. We'll see you all back in about 20 minutes.